Let us study chemistry together with CBSE chemistry tips and tricks.
A welding fuel gas contains carbon and hydrogen only. Burning a small sample of it in oxygen gives 3.38 gram carbon dioxide, 0.69 gram water and no other product. A volume of 10 liter of this welding gas is found to weigh 11.6 gram. Calculate the empirical formula, molar mass of the gas and its molecular formula. As per the question, the fuel gas contain only two type of elements, right? Which are they? Carbon and hydrogen. From the mass of carbon dioxide, we can find the mass of carbon, and from the mass of water, we can find the mass of hydrogen. Hope all of you understand. From the mass of carbon dioxide, we can find the mass of carbon, and from the mass of water, we can find the mass of hydrogen. What is the molar mass of carbon dioxide? Molar mass of carbon dioxide is carbon is 12 plus oxygen is 16 and 2 oxygen is there, so 44. So what is the meaning of that? 44 gram of carbon dioxide contain how much carbon? 12 gram of carbon, correct, right? 44 gram of CO2 contain 12 gram of carbon, correct, right? Now what is the amount of carbon dioxide in the question? It is 3.38 gram, and we are supposed to find how much carbon will be there in 3.38 gram of CO2. Cross multiply it. 44x is equal to 12 into 3.38. So x is equal to what? 12 into 3.38 by 44. On calculating, you will get 0.982 gram. 92 gram. So we got what? Mass of carbon. Mass of carbon is equal to what? 0.92 gram. Okay. Similarly, we can find the mass of hydrogen. What is the molar mass of water? Water is what? H₂O, right? Water is H₂O, correct? Okay. H₂O. Hydrogen is 1. 2 hydrogen is there plus oxygen. So what is that? 18. Correct? Now, what we can say? 18 gram of water contain how much hydrogen? 2 gram of H2. As per the question, how much water is there? 0.690. So 0.690 gram of water contain how much hydrogen? Okay, H. How much hydrogen? You're not supposed to write H2, okay, H. Okay, now cross multiply it. 18 into x is equal to 2 into 0.69. So x is equal to what? 2 into 0.69 by 18. On calculating, you will get 0.077 gram. So we got the mass of hydrogen and we got the mass of carbon, right? Now what is the total mass? Total mass will be equal to what? Mass of carbon plus mass of hydrogen, correct? See, as per the question, the welding gas only contain carbon and hydrogen. So total mass is equal to what? 0.92 gram plus 0.077 gram. And what you will get? Your answer will be 0.997 gram. So we got the total mass, right? For finding the empirical formula, we need percentage of each atoms, right? So for finding that, percentage of carbon is equal to mass of carbon by total mass of the welding gas into 100%. On calculating, you will get 92.3%. And percentage of hydrogen will be what? So you can either subtract this number from 100, or you can calculate it directly. Okay, 0.077 by 0.997 into 100 percentage, and you will be getting like 7.7 percentage. So we got the percentage of each atoms, right? Now we can find what? We can find the empirical formula directly. For finding the empirical formula, you have to draw a table like this, right? First column element, second percentage composition, third one atomic mass, fourth column percentage by atomic mass, fifth one is simple ratio, and last one is whole number ratio. Okay, so which are the elements? Carbon, hydrogen. And what is the percentage of carbon? 92.3, and for hydrogen it is 7.7. What is atomic mass of carbon? 12. For hydrogen it is 1. Now percentage by atomic mass. So what is that? 92.3 by 12 and 7.7 by 1. On dividing you will get here 7.69 and here 7.7. See, 7.69 is approximately equal to what? 7.7, right? Now what you have to do for finding the simple ratio? For finding the simple ratio, you have to choose the smallest number among these two. But here you can see both are same, right? So you can choose any of that. So I choose 7.7 and divide both number with that. Okay, so 7.7 divided by 7.7. Here also 7.7 by 7.7. So what is that? Whole number. It is already a whole number, right? So just copy it to the last column. And what is the empirical formula? It's very easy. C1H1, or you can say CH. Okay, C1H1 or CH. So we got the first part, right? We got the answer of the first sub question. That means empirical formula. Now we can move to the second sub question. That is, we have to find the molar mass of the gas. Check the question again. A volume of 10 liter. So volume is given 10, right? At STP, the welding gas is found to weigh 11.6 grams. So mass is given, right? What is mass? Mass is equal to 11.6 gram. So volume is 10 liter and mass is 11.6 gram. Okay, now what we have to find? Molar mass. See, you have direct equation, right? Number of moles is equal to number of moles, small n is equal to mass by molar mass. Also number of moles is equal to what? If it is gas, then it is volume by 22.4. Now see, we are going to use this part, okay? What is mass? 11.6. What is molar mass? Molar mass we have to find. What is volume? Volume is 10 liter. And what about the denominator? 22.4. Okay, cross multiply. What you will get? Molar mass, or 10 into molar mass is equal to 11.6 into 22.4, and molar mass is equal to 11.6 into 22.4 divided by 10. So what you will get on calculating? On calculating we will get 26 gram per mole. 26 gram per mole. So we got the molar mass of the gas. Now what we have to find? We have to find the molecular formula, right? Molecular formula. For finding the molecular formula, you must know these two equations. N is equal to molecular mass by empirical formula mass, and molecular formula is equal to N times empirical formula. So first we can find N. Very easy, okay? Very easy. How to find? N is equal to molecular mass. What is that? 26 by empirical formula mass, right? Empirical formula mass. Correct? So what is that? See, from here you can find carbon 12 and hydrogen. What is the atomic mass? 1. So 26 by 13, what you will get? 2. Now our final step, molecular formula is what? N times. So 2 times empirical formula. What is that? CH. Now, see, you can distribute it. So it become what? C2H2. So we got the molecular formula, that is C2H2. Hope all of you understand.